This section of notes is on section 2-7, graphing linear inequalities. Okay, now we graphed linear equations earlier, which is just a line basically. So this is the same thing, just a little bit more added to it. Okay, what linear inequalities are, it's the same thing as a linear equation, with this time, instead of having an equal sign, we have inequality symbols, whether it's less than, greater than, less than or equal to, greater than or equal to. Now there's two differences compared to graphing linear equations. First thing you have to look at or worry about is you have two different types of lines. You're either going to have a solid line or you're going to have a dotted line, okay, or dashed line you can call it. Now you graph a solid line if your equation or inequality is y is less than or equal to, or y is greater than or equal to. Okay, so this symbol here, it's going to be a solid line. See how I have y is less than or equal to, and it's solid. Y is greater than or equal to, and it's solid. Then for a dashed line, if you just have the regular inequality without the equal to part, then it's going to be a dashed line. Think of this kind of like your open dot versus solid dot. Open dot, open line, solid dot, solid line. Okay, now you're graphing. Okay, so now we have a boundary. So since before it was y equals, you have specific points. Now it's y is less than a whole bunch of answers. So because you have a whole field or range of or array of answers, we have a shaded region that give answers that make this inequality true. So that's why we shade a region. Now you're going to shade either above or below the line, one or the other. And a real nice easy way of looking at it as, if it's less than, you're going to shade below the line. So less than, it's shaded below, greater than, above. Okay, same thing on here. Y is less than you shade below, greater than, you shade above. So again, two things. One, what kind of line is it? Solid line or dotted line? Two, where are you shading? Below or above? And again, it depends if it's less than, greater than, greater than. Notice how these two graphs are pretty much exactly the same except for the dashed line versus solid line. Same thing with these two graphs. Pretty much the same thing. Dashed line versus solid line. And again, because they're both greater than, they're both above the line, only difference being solid and dashed. Okay? So let's look at another example. Another way of doing this is you can do what I just said before, look at above or greater than, above if it's greater than, or below if it's less than. Another way for doing this is picking a point in the test to see if that point works. Okay? So here, this is the exact graph and inequality as above. Now where's the shading going to be? Above, below. First of all, notice how it's less than, so it's dashed. Okay, so now all I'm going to do is I'm going to pick any point above, that's not on the line. Pick anything. So easiest point I'm going to pick here is 0. It's a point that's not on the line. So if I pick 0, 0, I'm going to substitute it into inequality. So 0 goes in for y, 0 goes in for x. So 0 is less than 1. Now you got to say, is that true or false? Okay, so 0 is less than 1. That's true. If you pick a point that gives you a true statement, you shade that side of the line. So since this is true, I'm going to shade the side of the line that contains 0, 0. And notice how this method also coincides with what we said above, that is y is less than you shade below. And it's, again, it's below the line. The shading is going down. Okay? So I pick another point that's not on the line. Say I pick a point on the other side. Say -4, 7. Okay? Again, I substitute these values into my inequality. So 7 goes in for y. -4 goes in for x. Okay? So now, true or false? Is 7 less than -3? Answer is false. So if that's false, that means all the numbers on this side of the line are wrong. So nothing is shaded. That means the other side is correct. So if you get a false answer, you shade the opposite side of the line where that false point was found. Okay, because that means this side is going to be the wrong side, and this side is going to be the correct side. It's the correct or the true side. The other side is the wrong or the false side. Okay, and you can see the connection from the previous material we did with the true and false, all real numbers, no solution, all that bit. Okay, so hoping seeing some kind of connection here. Okay, let's look at a couple more examples. Again, it's really the same thing. Now I shaded these in here for you, but again, I just want to explain them. So we have y is less than the absolute value of x minus 2 minus 5. Now if you think back to the irregular equation, okay, this is an absolute value equation of v that's shifted to the right 2 and down 5. Okay, so to the right 2, there's my vertex. Okay, so here's my v. Now that's if it's an equation. But again, as you see in the problem here, it's an inequality. So because of this symbol, it's a dashed v. Now pick a point that's not on the v. Okay? So, oh, actually, before I do that, it's less than. If it's less than, you shade below the v. So the shading you see on your notes is everything below the v. Say I wanted you to make it the pickup point. Again, it doesn't really matter. You can just look at it as below, above. Okay? So say I pick a point. So say I pick this point right here that's not on the v. So that point is 1, 2. Alright? So I'm going to substitute it into inequality. So I did that below here. 2 goes in for y, 1 goes in for x. All the work worked out. 2 is less than negative 4. True or false? So since that's false, you don't shade this side. Shade the other side. So we're going to shade the side opposite of the one you picked. So since we picked the inside of the v, and the inside of the v was false, it doesn't work. Shade the other side, which is what we did. The side below the v. Okay? Okay, let's go to the next one. What if the inequality is y is greater than or equal to? So again, it's the same exact v. This is greater than or equal to, so it's going to be a solid line. Again, because of the equal to. Solid. So now, greater than. Greater than means we shade above the v. So we shade everything above the v. So that's why this area gets shaded. Now, what if I pick the exact same point? Or not the exact same point. Pick a point in the v. So this point's in the shaded region, so you expect when I substitute it in, you're going to get a true statement. So this point is 4, 3. When I substitute 4, 3, as you can see in the work here, 3 goes in for y, 4 goes in for x. So when you substitute it in, it works out to be 2 is greater than negative 3. True or false? Is 2 bigger than negative 3? Absolutely. So it's true. So that means you shade this side. So if you look at that V, it kind of looks like a cup, right? So since the point was inside the cup, shade the side inside the cup. So we shade the inside of the V. So this means that if you pick any point inside this V, it'll give you a true statement. Pick any point outside the V, out here somewhere, and you'll get a false statement. It's not going to work. Okay, so look at another example. Okay, say you're given something like this. 12x minus 6y is less than 18. Okay, first thing I do is got to graph this. So we graph it. Either you find x and y intercepts, plot them, 2 points, draw your we talked about before, or simply just solve it for y. So solve y. Subtract 12x from both sides. Divide by negative 6. And again, since you divide it by negative, remember, don't forget to switch your symbol once you divide by negative. And you get y is greater than 2x minus 3. Again, symbol switched because we divided by negative. So the same thing as graphing y equals 2x minus 3. Same thing as graphing that. So start the y-intercept, negative 3. Then use your slope. Up 2 to the right 1. Up 2 to the right 1. There's our 2 points. Draw your line. And again, you're drawing a dashed line because of that symbol. That's why it's dashed. Now what we got to do is shade our region. So which side we shade? Is looking at y is greater than. So since it's greater than, that means shade above the graph. So if I shade above the graph, if I draw up arrows, see down here, I hit the line. I can't go any higher. So it's not down here. This is above the line because you can keep going up. Okay, so this is going to be my shaded side. So with this shaded region is going to be your final graph. Now, if you want to pick a point to see if it works or not, an easy one to always pick is the origin, 0, 0, if you can. So say I choose 0, 0, 0. Now, if I'm looking at this, it's already in a shaded region, so I should get a true statement, because it's already on the right side. So when I substitute 0 in for y, 0 in for x, I get 0 is bigger than negative 3, which is true. So we did shade the correct side. Say I pick 4, 0. It's on the wrong side, so you should get false. So when I substitute 4 in for x, 0 in for y, I get 0 is bigger than 5. 0 is not bigger than 5. That's false. So this point right here on the blank side is on the wrong side of the fence. That side is correct. Okay, so again, if you're going to get a false statement, you shade the other side. If it's a true statement, you shade that side. And then again, this symbol here, things like open dot, close dot, dashed line, solid line. Okay, you can look at a few more examples. Okay, if we look at letter B. If I were to graph y equals 3x, okay, graphing this, the y-intercept here is 0, because it has 3x plus 0. Y-intercept is 0, use your slope. Up 3 to the right 1. There's my 2 points. Solid line. Okay, now we choose a side. It's y is greater than 3x, so that means we're choosing the side above the line. So where can I draw up arrows from? If I draw up arrows from down here, I hit the line. I can't go higher. So it's going to have to be this side of the line. That would be my final answer. Okay? Alright, please work on the following practice problems. Again, if you have questions, please work together. This reviews all the stuff with graphing equations, for linear equations, and absolute value equations.